We looked in a previous video at how we can handle errors when we discover them. But the question comes to mind is, how do we discover them? What are the various means that we have to do that, and which one is used by Ethernet? So let's take a look at them. And by the way, these can get mathematically involved. The first one, parity, here is pretty easy. The other two are a little more involved, and I'm not going to go into detail about how to do those, but I'll give you some references. So first of all, in parity, I will describe how we do parity. We have this byte here, 011, 01, 001. And you notice that there are 4 ones here, 1, 2, 3, 4. So that's an even number of ones. So what I can do is the sender can add an extra 1 at the end that indicates even, and maybe a 0 indicates odd. So I add this extra 1 here at the end of it, and I send that. Now the receiver receives this and says, oh, there's a 1 at the end. That means that there must be an even number of ones up here. Let me see. 1, 2, 3, 4, 5. That's an odd number. So what happened here is this bit was a 0 here, and it now has become a 1 here. Somehow it got corrupted. So it got flipped, and we have an error. So now the receiver sees that 1. It says, it's odd, not even, and so this piece of data here, this byte, was corrupted, and it can now use its error handling, and in this case, because it's layer 2, it's just going to drop it. The checksum is a little more advanced. It's going to take the first 2 bytes and add them together using something called ones complement addition. Now, I'm not going to explain how ones complement addition works, other than to say if you have 4 digits and you end up, after you add them together with 5 digits, you take that one at the front and you move back around and add it back in at the end. That's basically how ones complement works. Then each successive byte is added to the sum that you got up here using ones complement addition. Finally, the final sum is converted using a ones complement operation, which again I won't try to go into detail to describe. And then the result is appended to the end of the message. And then the receiver does the same calculation. If it matches, the message is okay. Now, if you're interested, this video here, which is fairly short and I did not write, I did not produce, gives a very clear explanation where the guy sits with a pencil and piece of paper and goes through how the checksum is done, and it's really quite fascinating. The final one is the CRC, and it can get very complex. This is the one that we do use in Ethernet frames. Remember that the trailer is a CRC frame. So it's a complex formula by which bits are cycled through a register and checked for accuracy. Again, we're not going to go into the details of it because of the time it would take. It's beyond the scope of what we need to know anyway. So if you are interested in this technique, here's a video on how that calculation is done. And here's a pretty good article that talks about all 3 of them. Thank you.